Hello, today we're going to talk about relative frequency. Now, relative frequency is just experimental probability. Relative frequency would just mean the frequency is how often we see something, and it's relative to the total number of times we've run an experiment. So, how many times did we get what we wanted out of the total number of times we ran the experiment? Frequency relative to the total. So it's almost identical to how we would think about probability. Connected with relative frequency and probability in general, we have the idea of fairness. So if a game is fair, it means that all of the outcomes are equally likely. Like if we throw a normal dice, we have a probability of 1/6 of getting every single outcome. So we would say that a normal dice, is fair because all of the outcomes, all of the faces are equally likely to appear. Biased is the word we use for when something is not fair. So when all of the outcomes aren't equally likely. And we'd say that that's unfair or biased. Now, an important idea that we've touched on before is if we add up the probabilities of all of the possible outcomes, they must equal 1. So the total probability, the certainty, is 1. And if we add up the probabilities of every possible outcome, well, we have to have gotten at least one of those outcomes, if that's all the possible outcomes. So when we add up the probabilities, we have to get 1. Something certainly happened. So the probability of anything happening, we don't mind what happened, must be 1 because something certainly happened. As an example, for a fair coin, so an unbiased coin, the probability of getting a head plus the probability of getting a tail would be, this is it written out in probability language, would be probability of getting a head is a half plus the probability of getting a tail is a half, and we add a half and a half and we get 1. So these are all of the possible outcomes that we can get when we flip a coin. We could get a head or a tail, and when we add those probabilities together, we get 1. And that's true anytime you write out all the possible outcomes, all the probabilities of the possible outcomes, we add them all together and we get 1. And this is a really important idea in probability. Now, let's look at a specific type of relative frequency type question. So a spinner is spun 20 times and we're given a table of the results. So we have the color of each part of the spinner. We have red, yellow, or green. And the red came up, it had a frequency of 10. It came up 10 times, and the green came up 3 times. Now, how many times did it land on yellow? How many times when we spun the spinner, how many times did our arrow land on yellow? Well, I know that it came up 10 times on red and 3 times on green, and the only other color remaining is yellow. So if I took my total, so if I added up all of these 3 frequencies, I'd have to get 20 because it landed on one of these 3 20 times. So if I add up my 10 plus my yellow plus my 3 for green, that must add up to 20. So I'd have 20 is equal to 10 plus yellow plus 3. So I'd end up with yellow plus 13. I have 13 plus yellow must add up to all of the times the spinner was spun, would be 20. So if I take 13 away from both sides, I must have gotten yellow 7 times. So I can put that in there, put it in a different color. I must have gotten yellow 7 times. Now we can check our answer very easily because if we add up all of these frequencies, we have to get 20. 10 plus 7 is 17 plus 3 is 20. So the spinner had to land on one of these 3 colors. So if we add up all of the different times that it landed on each color, we have to get the total number of times we ran the experiment. So that's our first part. What's the relative frequency of each color? Well, we're going to use our relative frequency definition, which again is very much the same as what we would have argued for our probability. If I want to know the relative frequency of getting a red, it would be the number of times I got a red out of the total number of times I got an experiment. What I want out of my total. And I use OR-F for my relative frequency of getting a red would be 10 out of 20. I can put that in my calculator and I get a half. The relative frequency of getting yellow is going to be, I got 7 yellows out of 20 times I ran the experiment. So the wanted is the number of times I got yellow out of 20. And there's something simplifying to do there. So that's just 7 out of 20. And the relative frequency of getting a green would be 3 out of 20. And again, we can't simplify that down. We can put it on our calculator to check. If you prefer to put it in decimal places, that's perfectly fine as well. Finally, based on this, is the spinner fair or biased? Well, I go back to my definition. What does it mean for something to be fair? For a fair game, all the outcomes are equally likely. Well, are all of these equally likely? No. I came up with red and yellow way more than I came up with green. So for a relative frequency question, they don't have to be exactly the same probability because this is an experiment. It's not the exact probability. It's getting an idea of what the probability would be. But there are way more reds and yellows than there are greens. Now, something that's important is we haven't run this experiment very often. This could have just been bad luck. Green could have just been having bad luck. And we could have ended up that this could be a fair spinner if we ran the experiment like 1,000 times and saw if we were getting very different numbers for each color. But based on the experiment we've done so far, it would look like this is a biased spinner because we've got way fewer greens. The relative frequency of getting a green is way lower than the other two. So I would say it's biased, as the relative frequency of getting a green is much lower. Than the other colors. And that's what we need for relative frequency for now.